Welcome to Rges Algebra 2. This is section 2.4. We're continuing on with functions and how to graph them. The first thing I want to do is explain to you how you quickly and easily identify whether something is a function. A function means that for every independent variable, or value of the x we can think of, there will only be one value of the y. So if a graph looks like this, and for every x along it, I only have one y value, this is a function. Now, I could also have a point at which my domain stops, and it would still be a function. Okay, so this is an illustration of a function. We call it, sometimes people call it the vertical line test. If I can draw a vertical line anywhere and I only have one, not more than one, value of y, then for wherever I would draw that vertical line, then that would be a function. Something that illustrates something that is not a function would be, for instance, if I have a parabola going out this direction. Now notice if I drew a vertical line here, I have two values for my y for this value for x right here. So that would not be a function. And so it's a very quick and easy visual test for whether or not something is a function. Every group of ordered pairs is a relationship. And these are still important, but they're just not functions in the sense that whenever I'm changing my independent variable, I only have one answer for the y. Okay, so the next thing I want to do is look at, let's look at these two examples they give you here. The first one is y squared equals x. Okay, you want your y on the left-hand side and solving like it is here. So if I plugged in values for x and y, I could plug in a 0 for the x, and so on the right side, what y would I square to get 0? And the answer would still be 0. If I plugged in a 1, okay, what do I have to square to get 1? I could square a 1 to get 1. 1 squared is 1. Or I could square a negative 1, because negative 1 squared is also 1. So you're seeing how this goes. What if I have a 4 here? What do I need to square to get 4? Well, I could square a 2, but I could also square a negative 2. So that's really all I need to do to graph that. 0, 0. If I have 1, the value would be 1 here, positive 1, sorry, I'm getting ornery, and a negative 1. If I have 4, I would get a positive 2 and a negative 2. And what we have here is a parabola going kind of tipped on its side, going in this direction. Is it a function? Well, for any value, here's a value for x. If I look at my value for y, to be a function, I only can have one possible value, but here I have two, so this is not a function. Now for this next example, I have an absolute value relationship. And so I'm going to plug in a value for x and solve for y. Okay, let's say I have the value 0. Okay, well, what the absolute value of what would equal 0? Well, that would be 0. Let's say I have the value of 1. The absolute value of what would equal 1? Well, either 1 or negative 1. If I had 2, it would be either 2 or negative 2, etc. What if I had a negative value for my x? Well, if you have a negative value for the x, the absolute value of what number could give me a negative? And the answer is none. Okay, so there's no value there. So this is kind of helping me to define my range. All right, so if I were to graph that one, 0 and 0, if I have 1, I'm going to go to 1 and negative 1. If I have 2, I'm going to go to 2 and negative 2. In some ways, this is looking very similar to the points I calculated before in the last problem. The difference is when I graph this is not a parabola, but these are actually, I missed the points, but these are actually discrete points going up and down like this. There would be no negative value of x that would cause this equation to work, and so this is outside this section here. My negative numbers are outside my domain. Okay, if you look on page then 67, let's go down these answers Q1 through Q10 fairly quickly. It says, what axioms are used when I have 4? This is an interesting one here. I've got 4, 3 plus x, and I am changing that to 4x plus 12. Well, notice I first do the distribution, and I'm going to get 12 plus 4x, but because then I've changed the order to get from there to there, so I first have distribution, and then I have the commutative properties. 2 properties are being shown in that one. If we were to solve the next one, we would gather our x terms to negative 4x equals 14. So x equals negative 14 fourths, which can be reduced to negative 7 halves, which would be the proper answer. For 3, we're just simplifying by gathering like terms, and we would get negative 4x minus 14. The next one is a FOIL. You would get 6x squared plus 13x minus 5. Number 5, 50 is 40% of what number? Well, I like to first pick up the 10%. 10% would be taking that 50 and moving the place value over 1, so that would be 5. So if I have 40%, I would take 4 times the 5, or 20. So 40% would be 20. And I find that a very easy way to do percents in my head. If you were to write 5/8 as a decimal, you would simply have to take the 5 and divide it by 8. I would get 6 for 48. This would be, this would be 2 for 16, remainder 4, and that would go in evenly 5. So it's 0.625. Number 7, a parallelogram. Parallelogram simply has a parallel lines in one direction and parallel lines in the other direction. The length of the vertical one or the horizontal ones versus the side ones is irrelevant. If I were doing this more technically, I would write those little arrows on those 2 lines which indicate they're parallel, and a different set of arrows on these 2 lines to indicate that they are parallel to one another. So that's a parallelogram. Lines that are parallel in both directions. For 8, you're isolating the x. In an inequality, I could say just solve it. And so I would divide by 5. No need to flip the inequality sign. I would leave it the same because I'm not doing a negative. 34th over 5, and that cannot be simplified. Write an expression for 3 less than twice. Okay, always start with the other number and then take 3 less or 3 more or whatever. So the other value, when I say less than something, start with the something twice x and then take away the 3. Okay, sometimes students struggle with that one. And the absolute value of any positive number is the number itself. For 10, the absolute value of 13 is just 13. Okay, so as you are doing problems 1 through 10, or I think I asked for them to be, let's see, odd. So just these, very often you'll find it better to solve for the y first. It doesn't really matter, but for instance in number 5 you might want to solve for y, and then of course you're just making your t-charts for each one, plugging in values for x and solving values for y. Most of these are very straightforward, and then the ones that not so much so, like 7, follow the example that I gave you in the beginning of the lesson. And it will you can bring any questions you have about those. A couple of them are a little bit tricky, but I'd like you to stew on those yourself before I reveal my hand and show you the answers. But for 11 through 26, again, you're doing only the odd ones, and it's very, very straightforward, because whatever the curve, if you have a vertical line test and only one value, for every value of x, only one value of y, then that is a function. However, if you have something where you would go, let's say, well, even something like this, and for a value of x, notice for one of the values of x I didn't draw it so it was very clear, but maybe it went out like this. For one of those values of x, I might only have one value for y, but not for every single one. There I have 2 values, and there I have 2 values. If you have anything like that, it's not a function. So those are just visually solved.